Hey everybody, today we will do another problem, and it's going to be a digital logic problem again. It's called it's a digital logic. Okay, so it's going to be the POS. POS. It stands for product of sum. Product of sum. So, okay, so last time we learned about sum of product, right? This is product sum. We have two. We have S of P and P of S. So we're learning about this today. So there is something it's called the standard the standard POS form. The standard POS form. Right. So standard POS form. Right. So yes, last time I said that SOP does not stand for standard operating procedures, right? So I just want to put that over there. POS, it's product sum, and SOP is sum of product. Sum of product. Okay, so let's get this started. Let's start doing some. So we have to put some stuff in standard form, like everything else, right? So there's some fractions. If you're going to take in elementary algebra or elementary mathematics in elementary school, you might be asked to put a certain fraction in the lowest terms, right? Or reduce it to the lowest term. In this case, also there is a standard how to get this stuff done, right? Okay, so we will start with the problem. It says convert the following expression into standard POS form. Convert the following Boolean expression into standard POS form. Okay. So last time we learned about the SOP, right? The SOP, we have some parentheses, right? In the SOP, we had something like this, right? In between, we had plus sign, right? And over here, we have something like this. We had X, we had, A, B, C, and over here also we had, in order to be standard, we had A, A dot B, A dot B dot C, right? Right? So this is the middle. You can see you have a plus, right? Sign in the middle. What this is does add the product, right? That's why it's called SOP, sum of product. This actually is like multiplying, right? But with the difference that we playing with the N gate. We do an N gates right here. So we using the N operator, called the N operator. So right here we have the N operator, right? And so now we're doing the opposite. We're changing this guy and we're changing this guy to get the POS. Now we're doing product of sum. Product of sum, which means that this guy is going to be a multiplication, which in technically in logic is an N gate, right? So with that being said, let's get started, right? So let's do this. So now, as you can imagine, that the problem is going to give us, it's going to be giving us in the form of something, right? And that something is called like this. So it says the following expression is ABC okay, so ABC, A plus B plus C, right? That's the first. And one is a not B, right? A or B or C, right? Remember, right here I can say plus, right? But what I mean by plus, but this guy right here, that this sign, I mean or. It's a gate, right? A or B, okay, A, right? Or B or C, right? Which means that this gate right here, A or not B, right? Not B or C, right? So not B is negated. So if this given value for this is 0, then negated that is 1, right? And so forth. Right. Now, let's get the next term. And this is not B times, right? Not B, C, not D, right? Okay, so what this is doing now is that multiplying now, right? In the last term over here. So let me just explain this in a little while. In a couple more minutes, I will explain this. So right now we have this term, right? So we have B, C, and D, and we have again an or you can say a plus, right? Not B plus C plus not D, right? Okay. So now that is with A, B, C, and this one has a D, right? So in this case, I have right here 2, not B, not C, right? So, okay, so this is it, right? What I'm trying to say, what I was trying to explain right here, that notice that now instead of having the plus sign, I have a dot, like a dot product in between, which is called a dot operator, right? But it's technically it's an N, right? And operator, right? Now, but what is, it's a product of sums, right? Product of sum. Why is a product? Because I have, okay, I have a dot operator or an and operator, right? In the middle, in this parenthesis, I have sum, right? Sum. I have a sum, right? But I have in the middle, well, not in the middle, but let me explain it. This something, right? This box, let's say the system, right? This box with that box, I am ending those two boxes, but this box has a bunch of products in there, has a bunch of resistors and transistors and capacitors and some electronic device, right? And this one also has a bunch of logic gates in there, a bunch of transistors, a bunch of resistors, and a bunch of electronic devices. Now, if you look at this, and eventually we probably will do some gates, but what it does is take the system and end it with the system and end it with the system. It's called, technically. And then, but inside those boxes, we know that we have B plus C plus D, right? Not D, right? Right? Not B plus C plus not D, right? And so forth and so forth, right? Also, I have, if you hear something in the background, is that, again, in this house, we praise the Lord, and somebody's praising the Lord now. So that's how we roll, right? We praise the Lord in this house. And that's it. I think that's the best thing to do. All this engineering stuff is all good, but I think praising the Lord is even better. Okay, so let's get this done. So now notice that I have A, B, C, D. I have A, B, C, and I have B, C, D. What, am I missing something, right? I have A over here. I have an A over here. Do I have an A over here? No, I don't have an A, right? I don't have an A. Do I have D? Do I have a D over here? Right? Do I have a D over here? I have a D over here. Well, I don't have a D over here. So that's how we can actually work. Now, remember last time that in this case, we can say that in this term, right here, we don't have D or not D, right? We're missing those terms, right? This one. Right here in this one, we don't have so we don't have A or not A, right? So recognizing that will help us what we need to do to solve this issue, right? Now let's start with this. So I have A, not B, A plus not B, plus C, right? That is equal to, remember last time we did something like this, right? We did A plus, or A and not A, right? We did something like that. Why? Because we were doing product, sum of product, right? Now we're doing product of sum. Product of sum, right? So now, last time we multiply it, right? This time we need to edit. Add a term here. So, okay, so we can say that in this case, we can say that A plus not B plus C plus another term, right? You can put like parentheses, and you can put this term, and this parenthesis closing this piece, plus something else. We can say plus not, what am I missing? I'm missing D, right? Plus D multiplied by not D, right? Close the parenthesis. So what I am doing over here, I need to add those pieces right here. But because this either way can be, we need to complete the combinations, right? I have to add one, make these two parentheses, and one, I want to add one to it, add one to this, add one of the D's, right, to one parenthesis, and the other D to the other piece inside the parenthesis, right? So now what I'm going to do is this. So I'm doing this. I'm doing A not plus not B plus C plus this guy. I get D, right? Now, remember, we're doing sum of product. No, we're doing product of sum, right? Product of sum, right? So now, in this case, I have this D, right? Now, I put another parenthesis, right? I'm multiplying, right? That's why it's called S, a sum of product of sum, right? Product of sum, right? So this is going to be A, not B, A plus not B plus a C plus not D, right? So that would be for this one. That would be for this guy. This is complete now. Now let's look the other ones. Now this is complete. This piece is complete, right? We have it that kind of, right? Now let's come over here and say, okay, so what about the middle piece, right? What am I missing? Well, over here we did not have a D, right? D, O, not D. Over here we don't have A, O, not A. Now let's bring this guy over here. Let's do the same. So it's going to be not B plus C plus not D. Okay, the same thing, right? So what was I missing? I was missing A, right? I was missing A in this guy. Missing A, right? So same thing. We do the following. We do not B. We do not B plus C plus not D, right? Again, plus, right? So now I am adding what? I am adding plus A, not A. Same thing. Make it to this, make a copy of that, and add one A to this one and another A to the other one, right? So we do now alphabetical order. We'll put the A first. So we have A plus not B plus C plus not D plus not D, right? Okay, so now let's end this with another piece, right? With another parenthesis, right? So now you can put this. Now not A, right? Not A plus not B plus C plus not D. Okay. So now we have this guy complete. This is already complete, right? This is complete. A, B, C, D. Right? So now what we do is put this together, right? So we need to put this in one whole expression, right? So now what we can do is the following. So we can start with the top. We can say A, not B, plus C, plus D, and with A plus not B plus C plus not D, right? Plus this, plus that, which is going to be right? A, not B, not C, not, actually just C. A, not B, not, A, not B, plus C, A plus not B plus C plus not D, right? Okay, now, and with this, right? And with not A, not A, not B, A not B, not C, right? Not C, not, right? A plus not B plus C plus not D, right? Okay, so now I'm not gonna have a room. I need to add this guy. I don't know if I have a room. We can try. If not, we can put it in the other and put it in the bottom. So A plus not B plus C plus D. Right. So right. So technically, right. So this is the standard POS, right? So that is the POS, right? The POS is this expression. Um, so that is the POS standard form of this expression, right? So we have, this was given to us, this was not in the standard form because we had A, B, C, D here, and we were missing terms, right? We actually used the tools of Boolean algebra, right, to make this the standard form POS. Thank you for watching, and I see you in the next video.